In this lesson, we're going to look at the area of polygons and how to calculate those. Now, polygons are closed figures made up of straight lines. So we're going to look at triangles, rectangles, squares, trapezoids, and parallelograms. So if you're just looking for a video on a particular shape, you can fast forward through this until you get to the shape you're looking for. All right, so we're going to start triangles. And the area formula for triangles is area equals 1/2 base times height. Now, a lot of my students were taught in the previous grade level that the formula was area equals base times height divided by 2. And that's really the same thing. But on our reference sheet that we get from the state, it shows it like this. So that's why I'm going to show it like that. And to do this, you can do the same thing you did here. You can just do base times height and then divide by 2. Or you could change this to 0.5 and do 0.5 times base times height. All right. So now one of the key things with polygons is the base and the height are always joined at a right angle. And this is critical. B and H are always joined by a right angle. Are always joined by a right angle. And the reason this is important is because if you want to find the base and the height of a shape, then look for the right angle. So that's the biggest issue my students have, is misidentifying the base and the height. And the reason is they're not looking for the right angle. And the right angle is always shown with a box. That's how you know it's a right angle, because it has a box. So when we're looking for the base and the height of a polygon, we're going to look for the right angle. So using that, what I just said, in this first triangle, here's the right angle, and that's connecting the base and the height. So it's connecting this line and this dashed line. Now this dashed line is dashed because it's not really part of the shape. But in order to give us the height of the triangle, they had to give us this measurement. All right, so it's not part of the shape, but it's there to give you the height of the triangle. Now it doesn't matter which one of these you call the base and which one you call the height. I know a lot of people get confused by that. All you're going to do is multiply those two numbers together, so it doesn't matter which one you call B and which one you call H. All right, so the base and the height are 8 and 3. So to find the area, again, I'm going to use this formula, 1/2 times the base times the height. I'm going to do 1/2 times 8 times 3. And so 8 times 3 is 24. And then take half of that. So half of 24 is 12. So the area of this triangle is 12 square inches. Remember, the units for area are always squared units. All right. This next one is the one that trips my students up more than any other. And the reason being is because my students always want to say that this 5 down here is the base. And I just realized there's a mistake in this problem. This right here should not be a 5. It should be a 4. Let me change this real quick. So my students like to say that this is the base because they mix up base with the English definition of the base. So in English and language arts, the base of something is what it rests on. So they say, okay, well, this is the bottom of it, so that must be the base. Well, in math, the base has nothing to do with how the shape is oriented. So I could take this shape and I could spin it around, and it's not going to change what's the base and what's the height. All right, the base and the height are always. So if you find the right angle, then you'll find the base and the height. So in this case, you have 3 and 4. And so the area is 1/2 times the base times the height. So 1/2 times 3 times 4. And again, it doesn't matter which one you call the base and which one you call the height, because you're just going to multiply them together. So now we do 3 times 4 is 12. Take half of that, divide it by 2, and you get 6. So the area is 6 square centimeters. All right, let's move on to the next shape. All right, so I got three shapes here for you. The first one we're going to do is a rectangle. All right, and the area of a rectangle is simply base times height. And again, the base and the height are connected with a right angle. There it is, right there. It's connecting the base and the height. So all we have to do is multiply 10 times 4, and we get that the area is 40 centimeters squared. Shape is a square, and the formula for the area of a square is actually the same as the formula for the area of a rectangle. Now, interestingly, if you were to Google the formula for the area of a square, it would not give you this. The formula that it would give you would be that the area equals S squared. S stands for the length of a side. So since in a square all the sides are the same length, if you just take one side and multiply it times itself, you'll get the area, because B and H are actually the same values. I just wanted to let you know that if you look it up, you're going to find a different formula. That formula is not on our state reference sheet, so I just used this one. And so the area is 5 times 5, or 25 square feet. Easy enough. The next is called a parallelogram. Parallelogram. And the formula for a parallelogram is the same as for a rectangle and a square. It's basically a rectangle that's been tilted. All right. Now, again, remember the base and the height, they're always connected by a right angle. Here it is. So there were no right angles in this shape. A parallelogram has no right angles. So they had to give us this measurement at a right angle to the base so that we would have the height. So that's why this is a dashed line. It's not part of the shape, but you needed that measurement because that's the height of the parallelogram. The base and the height are always connected by a right angle. So we just have 5 and 2. So the area is just 5 times 2, or 10 square meters. All right, last shape. There we go. This shape, on 2 of these, I'll just add another one. This shape is called a trapezoid. Trapezoid. Here, I got a little crazy. This is called a trapezoid. And a trapezoid can look like this, or it also can look like this. Both of these are trapezoids. That's supposed to be a straight line. Pretend like it is. A trapezoid is made up of two sides that are parallel to each other. So in this one, these two sides are parallel, and this one, these two sides are parallel. All right? So the formula for the area of a trapezoid is kind of an interesting one. This is probably the one my students have the most trouble with. The formula is 1/2 times the height times base 1 plus base 2. Now that's not saying b times 1 and b times 2. This is a subscript. This is a 1 below it. And this is just saying this is b number 1 and this is b number 2. And the b stands for base. So the base and the height are joined with a right angle. That's still true. Now, it's not shown, but there's also a right angle up here. Since these two lines are parallel and this line is perpendicular, it's perpendicular with both of them. So now you can see why there are two bases. The height is the distance between them, but 8 yards is a base and 6 yards is a base. It does not matter which one you call B1 and which one you call B2, because you're just going to add them together. So let's call this one B1 and we'll call this one B2. And so let's fill in our formula here. The height is the distance between them, between the two bases, so that's 5. And then B1 and B2 are 6 and 8, so we have 6 plus 8. Now, this is the other place my students get in trouble here. They forget about order of operations. Please excuse my dear Aunt Sally, PEMDAS. PEMDAS says do the parentheses first. So that means you need to do this first. You need to add the 6 plus 8 first. So now we have 1/2 times 5 times 6 plus 8 is 14. And now we have something that looks like the area of a triangle, right? You just multiply these two numbers together and then divide by 2. So 5 times 14, that's 70, divided by 2 is 35. So the area is 35 square yards. All right, let's look at, let's do this one real quick. So I'll say this is 4, this is 3, and this is 6. All right, so again, here's my right angle. This one, the right angle is actually part of the shape. So they didn't have to add it in with a dashed line like they did here. Now, since these two sides are parallel and this line's perpendicular, there's also a right angle up here. So again, you can see where the two bases are. The two bases are the two sides that are parallel, so that's 3 and 6. And this is the height, the distance between the two bases. So I'll label one of these B1 and one of them B2, and we'll just plug them into the formula. 1/2 times the height times B1 plus B2. So that would give me 1/2 times 4 times 3 plus 6. And again, make sure you follow order of operations and do the parentheses first. So I have 1/2 times 4 times 9. So 9 times 4 is 36. Divide that by 2, and you'll get 18. And I didn't put any units on there, so we don't have any units here. All right, so I hope that was useful to you. Until next time.